Did you know that subqueries and window functions are the two most important interview questions? Hello, my name is Sumesh Shukla, and in this particular video, I'll be helping you to understand subqueries and window functions with example. But before we start this video, don't forget to check out Scalar's free masterclass on Scalar's event page by leading industry experts. The link is in the description box. But before we start this video, don't forget to subscribe to our Scalar's YouTube channel. Let's get started. Now let's talk about window functions. Now this is something which makes your life easy and also add more functionalities while you are writing SQL queries. So let's try to first of all understand why we need a window function. I will try to explain this particular technique, which is window function, by taking one example. Let's say we have employee ID. So I'm creating a sample table. I'm having a name, I'm having salary, then department ID, and we are having some records. So here I'm having 01, 02, 03, 04, 05. So we have 5 employees, and I'm taking some sample names AA, BA, CK, DM, NK. Random salaries 10, 12, 11, 15, 10. Random departments D1, D2, D1, D2, D3. Now if I ask you to find out department wise average salary. Now in order to answer this question, we will be using the technique of group by. And if we try to generate the output, it would look something like this. We will have a output table with department ID and average of salary. And since we are having 3 departments, I will have 3 records over here, D1, D2 and D3, with D1 average being 10.5, because here I'm having one entry with 10 and 11, so 10 plus 11 divided by 2. Then D2 we have 12 and 15, so that is 13.5. 12 and 15 is 27, and D3 we only have one record, so 10. Now this is what I will get as an output when we try to find out the answer for this question. What is department wise average salary? Now this particular output is basically generated after applying group by. We have used the command group by, and this is the aggregated table which we have obtained as an output. But what if I do not want this table as an output? This is a separate table that is generated after applying the group by command. I do not need this separate table. This is a separate table. I do not need this separate table. So what I need these average values as a part of same table itself. So let's say I need average of department ID over this column itself. So corresponding to D1, I'll get 10.5. Corresponding to D2, I'll get 13.5. D1 10.5, D2 13.5, D3 10. And this is the additional column that I wanted to generate. Now how this is possible? This is possible by using what is known as windows function. Now window function is something which we apply in 2 stages or maybe 2 steps. The very first step is windowing or partitioning. So what is windowing and partitioning? Let's try to understand it with an example. So my step number 1 is I will create windows. Now here we will keep the example same. My objective is to generate this additional column, which is department wise average salary. So while we are creating windows or partitioning the data, we will partition the data according to the department ID. Let me show you this. So we have employee ID, we have name, we have salary, we have department ID, and let's generate the records. So 1, 2, 3, 4, 5. So here now my objective is to create windows. So all the records according to department number 1, I'll keep it together. So 01 AA, 10 Z1, 03 CK, 11 D1, then 02 BA, 12 D2, then 04 DM, 15 D2, and finally 05 NK, 10 D3. So here, if you closely observe what I have done, I have created some windows or partitions. So this is my window number 1, window number 2, window number 3, or if I have to highlight the partition, this is partition number 1 and this is partition number 2. So we have altogether 3 partitions, 1, 2 and 3. Now this is my step number 1 or stage number 1. So I'll write windowing over here, windowing, or it is known as partitioning, and I'll write 1 over here because this is stage number 1. Now once I am done with creating partitions, my next step is to apply aggregation function on each window. So my objective is to generate average of salary department wise. In the second stage, what I'm going to do, so again I will have all the columns, employee ID, name, salary, department ID, and let's generate the record 1, 2, 3, 4 and 5. Again 01, 03, 02, 04, 05, AA, CK, BA, DM, NK, 10, 11, 12, 15, 10, finally D1, D1, D2, D2 and D3. Now here what is my objective? My objective is to find out department wise average salary. So now on each of these salary window or salary partition, so we are going to apply the average aggregation function, average of salary. So I'm basically going to perform aggregation over each partition, aggregation over each partition. Now here I'm going to apply the aggregation function, which is average. So here we will apply the aggregation function average. Here also we will apply the aggregation function average, and here. Now if I apply, I'll get the value 10.5 over here, 10.5 over here, followed by 13.5 over here, 13.5 over here, followed by 10 over here, and this is my new column, which is average department salary. Now here we are not just limited to average. We can have multiple functions. We can have almost all kind of aggregation functions over here. We can have sum, we can have count, we can have minimum, which is min, we can have max. So all these aggregation functions can be applied over here together with the average. These are my aggregation functions. Now how we can write the query for this? So this was my stage number 2. How we can write the query? In order to write the query, we will again follow the 2 steps which we have discussed. So the query looks something like this. We need to select asterisk. Asterisk means I am interested in getting all the columns. So asterisk all the columns followed by comma. I need average of salary. I need to apply average of salary aggregation function over the window or over the partition which is partitioned by, so over partition by, the column name is department ID as average underscore dp underscore sal from the table employees. And this is how simple it is. Those who are worried about window function can see how easy window functions are. So let me just tell you again what we have done. Here you can see that we have applied average of salary, which is my aggregation function, over. We use the clause over to generate a window. So I'm saying generate a window, which is generated using the clause over. The window is partitioned by department ID, and this is what we have done, right? As average department salary. So this is the name of the new column from the table employees. So here we have applied 2 steps, step number 1 and step number 2. If I try to map the steps in my query, this is my step number 2 and this is my step number 1. Right? Simple. So let's now take one example to understand how we can apply window functions on a sample database. Now here I'm having a database named HR, and here you can see that we have following tables such as countries, departments, employees, job history, location and region. Now if I look into my employees table, so we'll write select star from the table employees underscore data. Now here please remember one thing, that I have already activated my HR database. So that is the reason I was able to query the table from the HR database. So here you can see that we have department ID and the salary of various employees and their employee ID. Now let's say I wanted to generate the following output. I need the full name of the employee, followed by his or her salary, followed by his or her department ID, and finally followed by the average department salary. Now here please remember one thing. If I need the data of all the employees, I cannot do that using group by, because group by returns you the aggregated table. Let me show you one example. Let's say if I have to find out department wise average salary, I can simply say select department ID, comma, average of salary from the table employees underscore data. Now if I execute this, oh sorry, we have to also group the data. So group by department ID. If I execute this particular query, I will get department wise average salary. But if I try to add, let's say, first name, I'll get error, because that is not possible. You can see that we will be having error, and the description of the error is that we haven't not added this particular column in the group by clause. So you cannot get the non-aggregated entries. You have to put all those columns in the group by statement. It is impossible to generate the following data or the following result using group by. Now that is the reason we have learnt about window functions. So let's now try to generate this output. Let's first of all select first name. So here we will use the concat function, concat first name with the space with last name as full name. Then we need salary, comma, we need department ID, and then I will apply the window functions. So we need average of salary over partition by department ID as average department salary, and here we have to just write from the table employees underscore data, and if I execute this we have the result. So this person so here you can see that we have two employees working in department 20, Michael and Pat Phi, and their individual salaries are 13,000, 6,000, but their department average is 9,500, which is the same entry for both of them. So this is how we can simply apply window functions. Before I move to the next topic, I just want all of you to concentrate on this particular result. By default, you can see that within each window, the data has been ordered according to the department ID. So if you closely observe, the very first row I'm having department ID as 0, which is the maybe the minimum department ID, and the last row is 110, which is the maximum department ID. Now since I have not added any order by clause within the window functions, the results are automatically sorted according to the ascending order of department ID. Now how we can change this and how we can apply more aggregation functions with order by, we will talk about this in the next slide. So let's now understand rank function. Rank is basically a aggregation function that works with the window function. But the reason we are trying to explain it in a more detailed way is because the way we create the window is little bit different from the regular window. So let's take one example. Let's create a sample table. Here we have employee ID as one of the column or maybe the field, then followed by name, salary, and department ID. Now let's create some sample data. So row number 1, record 2, record 3, record 4, record 5, 01, 02, 03, 04, 05, 06. Again, sample names AA, BA, CK, NM, TA, DT. Salaries 10, 15, 12, 11, 15, 11. Random departments D1, D3, D1, D2, D2, D3. Now, what is the objective of having a rank function? So let's say I wanted to generate an additional column over here. Let's say the name of the column is rank underscore, and I wanted to rank employees according to their salary within their department. So if I look into the department number 1, this is the employee in department number 1 followed by this employee. But among these two employees with the employee ID 03 and 01, the employee with 03 employee ID is having a salary of 12, and then 01 is having a salary of 10. So this person will get a rank of 1, while this person will get a rank of 2 within their department. Similarly, department number 2, this person will get a rank of 1, this person will get a rank of 2. Similarly, department number 3, this person will get a rank of 1, this person will get a rank of 2. Now how we can generate this column or a field using window functions. So again, we will apply the window function as regular in two steps that we have learned. So first of all, we will apply windowing operation. I have to again generate this column, employee ID, name, salary, department ID. And now while I'm creating the windows, I will make sure that within each window, the data is ordered according to the salary column in descending order. Now please carefully observe. I will start from department number 1. So 0, 0, 3. The reason I am putting this employee 03 as the first row or the first record is because among these two employees who are working in department number 1, this person is having a salary of 12 while this is having a salary of 10. So since I have to make sure that within each window my data is ordered according to the salary in descending order, I will place employee number 03 at my first row followed by 01 in my second row. Again, I'll do the same thing for other departments. So 05 TA, 15 D2, and then 04 NM, 11 D2. Similarly for D3, 02 BA, 15 D3, and 06 DT, 11 D3. Now here carefully observe what we have done. Within each department or within each window, so this is my window number 1, window 2, window 3, I have ordered my data according to the salary column in descending order. If you closely observe these two values, you will understand what we have done. And now what we have to do, we have to apply the aggregation operation as my step number 2. So let's move to the step number 2. So this was my step number 1. This is my stage number 2, where I'm going to aggregate the data, and the aggregation operation that we will apply is the rank function. So let's generate the stage number 2 output, employee ID followed by name followed by salary followed by department ID and the additional column, which is rank. Now again we have 6 entries or 6 records. So 01, 02, 03, 04, 05, 06. So here we have 03, 01, CK, AA, 12, 10, D1, D1, and this will be rank 1, rank 2. And other department 04, TA, NM, 15, 11, D2, D2, rank 1, rank 2, 02, 06, BA, DT, 15, 11, D3, D3, 1 and 2. Now if you carefully observe what we have done, within each window I have ranked the employee with their according to their salary in the department, and this is what the rank function is. Now let's first of all understand how to write this query. So we start with select. We need to select asterisk. Asterisk means I'm interested in selecting all the rows and columns. Asterisk. Then I need to apply the rank function. So rank round brackets over partition by department ID and order by salary in the descending order. So this is very important. I have to order my data within each window according to the salary column, but in descending order, so that within each window I can get the first row as the highest salaried employee, followed by second highest, third highest, and so on. And from the table employees underscore data. So this is how rank function works. But there are some more functions which are available in SQL. So we have functions like rank, dense rank, and the last one is row number. Now these three functions are very much similar to each other. Let's understand the difference. Take one sample data. So here I'm having a salary followed by how the rank function will work, how the dense rank function will work, and how the row number will work. So our row number के लिए I'm writing row underscore n, and let's create some rows or the records. Now please consider this as one window. This is one window. Within this window, I'm having a person with salary of 100, 98, 98, 95, 92, and 80. Now, how rank function will behave in this case? The person will get a rank of 1, 2, 2. Now here, the rank function will skip the rank and you will get 4 over here, followed by 5 and 6. What dense rank will do, it will not skip any rank. So you'll get 1, 2, 2, and 3, then 4, then 5. And row numbers are just raw numbers ranging from 1 to n. So 1, 2, 3, 4, 5, 6. So this is how we use rank functions, and this is how we can write the query for the rank functions in SQL. So let's now take one example to understand how we can use rank functions with window. So here we will look into the employees table, which is named as employees underscore data. Now let's say I wanted to find out that within each department, what are the various employees and their ranks. Rank according to their salary. So we will write select. I want all the columns. You can also select few columns like first name, department ID, salary. It is up to you, but I am selecting all the columns, followed by the function rank over partition by department ID. And please remember, it is very important to write the order by clause. Order by salary column in the descending order as RNK. RNK means rank from the table employees underscore data. Now here you can see that we have the following ranks generated. So let me expand this quickly for you. And here you can see that for department number 30, we have the following employees and their corresponding ranks 1, 2, 3, 4, 5, 6, because all of them are having different salaries. Now let's quickly also check out other functions like rank, dense rank, and row number. So dense underscore rank, and for the window function creation would remain the same. So I'll quickly copy this, put it over here. I'll copy this, put it over here, and I'll call this as D underscore RNK. Similarly, we will use row number and I'll call this as rn, and let's run this. Now here we can compare all the three functions. So let's navigate in this particular row, or maybe row number, department number 100. Here everyone is having the same salary, so no difference. Okay, let's focus on let's focus on department number 60. Now here you can see that I'm having two employees with the salary 4,800, 4,800. So here rank function has given 1, 2, 3, 3 and has skipped the fourth rank, so I'm getting 5. Here the dense rank function has given the rank 1, 2, 3, 3 and the fourth rank also. And here row numbers are just the raw numbers 1, 2, 3, 4, 5, which is basically the number of rows in a particular window. So this is how you can use the various ranking functions together with the window functions. Let's now understand what is subquery and how we can write a SQL query using subqueries. So first of all, let's take two examples. Let's say I have to find out. So I'm writing down the question and let me increase the so I'm writing down the question. Find the average salary of department or the executive department. Now, how we can answer this question? Here I'm having two tables. One is the employee table, which you guys can see over here. In the employees table, we have employee ID, first name, last name, and so on with the department ID. But I do not have the department name. Now, where I can get the department name? In the department data table, we have the details. So if I look into the department data table, select a start from department underscore data. I'll get the details of all the department names together with their department ID. So basically what we will do, there is one way to join these two tables and then apply the filter. So let's take the traditional way, or maybe the most simplest way. First, we will join the two tables and then we will perform the filter. So let's join the two tables. Select a star from the employees data table, and I'll call this as A. Inner join department data table, and I'll call this as B on A dot department ID is equal to B dot department ID, because department ID is basically the common column, the primary and the foreign key combination between both the tables. And when I do this, you can see that I'm having the joined table. Now I have to filter this where the department name is executive. So I'll write where B dot department name is equal to executive, and we are done. Now these are the entries wherever the department name is executive. If I want the average salary, I'll quickly change the star and I'll write average of A dot salary, because in the table number A, which is over here, I am having the salary column, so I get the average salary. But is this the best way to solve this question? Or maybe is this the best way to write down this query? Certainly no, this is not the best way, and you should not be joining the tables. The better way of doing this thing is to write down a subquery. Now what I am going to do, I will be using the department data table to find out the department ID where the department name is executive over here. So let's write down this query. Select star from department data where department name is equal to executive. And once we execute this, I have missed a equal to sign. When I execute this, here we have the department ID 90. Let's select only the department ID. Department ID. So I'm getting department ID as 90. Now I'll be using this value to filter the employees data table. So I'll write select star from the table employees underscore data, where department ID is equal to, and instead of writing 90 manually, I will provide this complete query, the inner query, the below query, as a subquery. So this query, which I have written over here, which is returning me the output 90, which is the department ID of the executive department, I'm using this output to filter this particular data, the employee data table. And let's execute this. And you can see that I'm having all the employees from department 90. Since I need the average of salary, so I'll write average of salary, and we are done. Right? So this is how we write subqueries. Now let's try to understand when to use a subquery versus when to join two tables. This is a very tricky situation for most of the students to choose whether to join or whether to use a subquery. Now it is not that difficult. Let me explain you with an example. So we will take two questions. The first question is find department name wise average salary. Now here, how my output would look like. Since I need department name wise average salary, I'll have two fields or two columns. One of them which will be department name, followed by average of salary. And here we will have the department names and we will have the average of salary. Now, if you guys closely observe, this particular column, which is department name, is from the table department data. And this particular column, which is salary, is from the employees data table. So here in the output of this query, is having columns or fields from two different tables. So the output is having fields from two different tables, right? Now let's take another example. Find average salary of executive department. Now here, if I ask you how the output would look like, it will be a single value, just average of salary, right? And we will only have one single answer. Let's say this is the average salary. But if we write down the query, here I will be using the executive department as a filter, right? So when you are having the output where you have the column or the field only from one table, which is employees data, I will not be joining the tables. So the learning from here is, when you have output which involves field from multiple tables, we have to join those tables. Join. We have to apply the join. We cannot generate this kind of output without performing join. But if we have the output from a single table, or maybe if we have a particular field in the output from a single table, we will use subquery. And this is the simple trick you guys can use to decide whether to use a subquery or whether to use a join. Let's now look into one example to understand when to use a subquery versus when to use a join. So here we have already solved this particular question using the subquery, where the objective was to find out executive department average salary, or maybe the average salary of the executive department. Now if you closely observe, here we have used the filter of the executive department in the subquery. So here we do not need to join the two tables. But let's say I need to find out department name wise average salary. So my objective is to find out department name wise average salary. So the very simple way of doing this thing is, we'll say select, first of all I'll join the two tables. So select a star from employees data A, inner join departments data B on A dot department ID is equal to B dot department ID. And here we have joined the two tables. Now my objective is to find out department name wise average salary. So department name is in the table B, so I'll write B dot department name. Then I need average of A dot salary, and here I have to write down group by clause, group by B dot department name, and we are done. Now here you can see that we have department name wise average salary. So this is quite easy. When you get into the practice, you will be easily able to segregate when to use the join or when to use a subquery. Now there are some rules which you have to understand while writing a subquery. So let's quickly go through the rules. The very first rule is subquery must be enclosed within parentheses. So let me take this previous query and we will try to run it without parentheses now. So I'll remove the parentheses over here. Now you can see that I have got a cross mark over here, and if I try to execute it, I'll get a error saying that you have some error in your SQL syntax. You can see over here. So this is the rule number one. We have to place the subquery always in the parentheses. The second clause is a subquery can only have one column in select clause unless multiple columns are in the main query of the subquery. Now what is the meaning of this? So let's again take this example. Now here if you closely observe, here I'm having department ID and I'm comparing my department ID with this particular column which returns one value, which basically mean I am comparing one value with one column. One value with one column. That's how the comparison is made. But if I put two columns over here, let's say employee ID also, that is something which will give you error. You can see that we have a cross mark because the mapping can only happen one to one. That's what the second rule while you write a subquery. Let's now understand the third rule of writing subquery. The between operator can be used with the subquery. Let me give you one example to understand this. Let's first of all find out the minimum and the maximum salary of employees working in department 30. So select max of salary from the table employees underscore data, where department ID is equal to 30. Now this will return me the maximum salary of department 30. Let's quickly copy this and convert this query as minimum salary. So here I'm having another query. Now I want all those employees who are earning between these two salaries, the minimum salary and the maximum salary of department 30. So we can write a subquery, we can write a main query which can accommodate these two subqueries using between clause. So select a star from the table employees underscore data where the salary between, I want this salary, so between the minimum salary, I'll put this in round brackets because that is the rule of subquery, and the maximum salary, and I'll put this one also in the round bracket, and finally a semicolon, and we can execute this. Now here you can find out that we are having all the employees who are earning between these two salaries, the minimum salary and the maximum salary of department 30. So that was our third rule. Let's understand the next rule. Now for the next rule, I do not have any demonstration for you, but the rule is blob, which is binary large object. So whenever you preserve images or the data which is in binary, because if you remember, the image data comes in a binary format, ones and zeros. And when you preserve this data in database, it is preserved as blob. So it is impossible, or maybe it is not possible, to use subqueries when your column, the reference column, is blob or C blob or nclob or B files. These are the file formats, or maybe the column, the data types with which you cannot use the subquery. Now these are the some rules which we have to keep in mind when we are writing subqueries. Let's now understand the difference between non-correlated subqueries and correlated subqueries. To understand the correlated and non-correlated subquery, we will take very simple example. Let's say I wanted to filter all those employees who are working in executive department. We have already seen the example. So let me write down the query for it. Select a star from employees data where the department ID is equal to, and here we have the subquery, select department ID from the table department data where department name is executive. So here, if we closely observe, there is no connection between these two subqueries. This is an independent subquery and this is an independent subquery. If I select this subquery, so in SQL, if I select this subquery and if I execute only this query, it will run independently. And this is what is the example for non-correlated subqueries, because there is no interaction, or maybe there is no dependency between these two queries. So non-correlated subquery. Now let's understand correlated subquery. In order to understand correlated subquery, I will be required to create a dummy table. So now let's understand the correlated subquery. In order to understand correlated subquery, we will take one example, and I'll be required to create one table which is having three fields: employee ID, name, and salary. I'll create the same table for 2 times because we have to compare the values. So it is the same table, but I'm creating for 2 times. Let's add some random data, and the same for here also. So 1, 2, 3, 4, A, B, C, D, and similarly over here 1, 2, 3, 4, then A, B, C, D, and here some random salaries. The same salary over here also. Now let's write down the query to understand what exactly a correlated subquery is. So the correlated subqueries looks something like this. Select. I'll call this table as E while this table as P. So I need E dot name comma E dot salary. From the table, let's assume that the table name is employee. So from the table employee followed by the where clause, where 2 is equal to, and then we have written a subquery. Select count of salary from the table employee P. Now this the same table, but we have referred it for 2 times with alias E and P. So from employees P, and there is a condition where P dot salary is greater than or equal to E dot salary. Please remember, we'll be first executing the inner query E dot salary. So this entire row will be taken. And now we will compare this salary, which is P dot salary, whether it is greater than or equal to E dot salary or not. Yes, it is. So we'll count. So because we have to count. So count will become 1. Then I will compare this one because I have to check how many salaries are there in my table P which are greater than this particular salary. So 6,900, is it greater than or equal to 7,000? No. 5,000, is it greater than or equal to 7,000? No. 2,000, is it greater or equal to 7,000? No. So I'll get the count here 1. Now 1 is not equal to 2. So this is not meeting the condition. So we will not get this row as an output. Now I have to move to the second row. Now my entry value is 6,900. So here I'll get 6,900. Now I will compare whether 7,000 is greater than or equal to 6,900. I'll get 1, yes. Whether 6,900 is greater than or equal to 6,900, yes. So instead of this 1, I'll get 2. Whether 5,000 is greater than or equal to 6,900, no. Whether 2,000 is greater than equal to greater than or equal to 6,900, no. Now here I'll get 2. So 2 is equal to 2. Condition has matched. So my output will be this particular row. So my output will be E dot name, which is B, and salary, which is 6,900 as my output. Now this particular query is helping us to find out the second highest salary. Now there are multiple ways to find out second highest salary. You can use limit, offset, but this is the way in which we can find out second highest salary using the concept of correlated subquery. Here what is happening, until and unless my second or the internal query is not executed successfully, my outer query will not execute. So there is a dependency between the internal query and the external query, and that is the reason this is known as the correlated subquery. So with this, we come to the end of this video. We hope that you guys found this video really helpful to understand subqueries and window function. Before you end this video, please like this video, share this video with your friends, and don't forget to hit the bell icon so that you never miss any update from us. I will see you in the next video.